In the most familiar version of modern American history, machines appear as the central actors in a story of recovery and progress. When the United States faced economic collapse, technological power supposedly stepped forward as the decisive solution. Factories expanded. Massive machines turned raw materials into products at unprecedented speed. Productivity rose. Employment eventually returned. The country rebuilt itself through steel, gears, and engines. This narrative appears everywhere. Industrial museums display towering machines as symbols of national resilience. Documentary films describe waves of mechanization as if they were inevitable forces moving history forward. Textbooks summarize decades of economic struggle with a few concise phrases: industrial expansion, technological innovation, increased productivity. The machines are presented almost like protagonists. Gigantic turbines generating electricity, assembly lines producing automobiles, agricultural harvesters covering acres in hours instead of days. Each machine appears as a step in a steady climb out of crisis. In this telling, the story seems straightforward. When the economy collapses, society innovates. When labor productivity falls, machines compensate. When demand rises again, industry scales up through mechanical power. Technology becomes the mechanism through which the nation stabilizes itself. The idea carries an intuitive appeal. Machines do not tire. They multiply human effort. They convert energy into motion with precision and consistency. If an economy struggles because production slows or costs rise, then more efficient machines appear to offer an obvious solution. Industrial growth therefore becomes closely associated with economic recovery. The early 20th century offers some of the most commonly cited examples. During periods of instability, factories invested heavily in mechanical systems that promised faster production and lower costs. Steel mills expanded their capacity through increasingly powerful rolling equipment. Railroads relied on stronger locomotives capable of hauling heavier loads across longer distances. Agricultural regions adopted mechanized equipment that reduced the amount of labor required to cultivate vast fields. The pattern seems simple. Machines increase output. Increased output lowers prices. Lower prices stimulate consumption. Consumption drives economic growth. Growth stabilizes the system. When historians describe these developments in broad terms, the machines themselves appear almost neutral. They are tools responding to economic necessity. Their existence seems to follow the same logic as gravity or momentum. In many public presentations of industrial history, the machines themselves dominate the visual narrative. Photographs show rows of workers dwarfed by enormous equipment. The machines look powerful, precise, and purposeful. Their scale reinforces the impression that technological systems possess their own internal momentum. The message becomes clear even without explicit explanation. Modern economies function because machines extend human capability. When crises emerge, the expansion of industrial machinery helps restore balance. This interpretation becomes particularly visible when discussing moments of severe economic disruption. During the Great Depression, for example, large infrastructure and industrial programs often appear in historical memory as symbols of national recovery. Massive hydroelectric dams, mechanized construction equipment, and expanded manufacturing facilities represent the moment when technological capability supposedly pulled the economy back from collapse. The machines appear again as stabilizing forces. Power plants generated electricity for growing cities. Industrial equipment produced consumer goods that reactivated markets. Construction machinery built roads, bridges, and public works projects that employed thousands. From this perspective, the machines seem to embody the practical solution to economic paralysis. Even when historians acknowledge the role of government policy or financial reform, Technology often remains at the center of the visual and symbolic narrative. Photographs of machinery fill the pages of books. Museums place large industrial artifacts at the center of exhibitions. The implication is rarely stated directly, but it becomes difficult to miss. Industrial machinery represents competence, scale, and order. When systems fail, the expansion of technology restores them. This framing also reinforces a broader cultural assumption. Technological progress equals social progress. If machines become more powerful and efficient, society will naturally become more prosperous and stable. Economic crises therefore appear as temporary interruptions in the long trajectory of technological advancement. The logic seems reassuring. As long as innovation continues, collapse can be reversed. Over time, this interpretation becomes so familiar that it begins to feel almost self-evident. Few people question the idea that machines played a central role in restoring economic growth during difficult periods of American history. The relationship between industrial expansion and national recovery becomes part of the cultural background. It appears in school curricula, historical documentaries, museum exhibits, and popular narratives about American ingenuity. The machines are not simply tools within the story. They are the story. Yet, when this narrative is examined closely, certain details begin to feel slightly out of alignment with its simplicity. The same decades that celebrated massive increases in industrial productivity also recorded persistent struggles over working conditions. Mechanization often coincided with waves of labor unrest rather than immediate stability. In some industries, the introduction of more efficient machines actually intensified economic volatility rather than resolving it. These observations do not necessarily contradict the broader narrative of technological progress, but they introduce a small uncertainty. If machines were truly the clear and decisive force pulling the economy out of crisis, the historical record might be expected to show a more consistent pattern of stabilization and improvement. Instead, the evidence sometimes appears more complicated, and that raises a quiet but important question. What exactly did those machines change? And what parts of the story have remained less visible? If the common narrative presents machines as the engines that restored economic stability, the historical record begins to look less seamless when examined more closely. The first irregularities appear in the relationship between productivity and labor. Industrial mechanization undeniably increased output in many sectors of the American economy. Steel production accelerated through improved furnaces and rolling mills. Automobile factories introduced assembly systems capable of producing vehicles at unprecedented scale. Agricultural machinery expanded the number of acres that a single farmer could cultivate. Measured strictly in terms of output, the numbers appear impressive, yet these increases in productivity often unfolded alongside persistent instability in employment. Mechanization did not always produce a smooth transition toward economic recovery. In several industries, the introduction of new machines reduced the number of workers required to produce the same quantity of goods. While overall production rose, individual workers sometimes faced shorter contracts, lower wages, or sudden layoffs when equipment replaced tasks that had previously required manual labor. This contradiction appears frequently in contemporary reports from the early 20th century. Factory managers described mechanical upgrades as essential for maintaining competitiveness. Labor organizations, meanwhile, recorded repeated concerns that mechanization allowed employers to reduce staffing levels while maintaining or increasing production targets. Both descriptions could be accurate at the same time. Higher productivity did not automatically translate into broader economic stability for workers themselves. In some industries, machines intensified the pace of labor rather than reducing it. Assembly line systems provide one of the most widely cited examples. The introduction of continuous production lines dramatically increased the number of goods that could be manufactured within a given period. However, workers on these lines often experienced a different reality than the narrative of technological liberation might suggest. Instead of eliminating repetitive labor, machines frequently reorganized it. Workers were assigned highly specific tasks, synchronized with the speed of the machinery. The rhythm of the machine determined the rhythm of human movement. Production targets were no longer limited by individual endurance, but by the operating capacity of the mechanical system. Observers at the time described assembly line work as physically demanding and mentally exhausting despite its apparent efficiency. This detail does not appear prominently in many simplified accounts of industrial recovery. The machines increased output, but they also reshaped the structure of work itself. Another inconsistency appears when examining the relationship between mechanization and economic volatility. In theory, more efficient production systems should stabilize markets by lowering costs and increasing supply. Yet historical economic data often show periods in which rapid industrial expansion coincided with sudden cycles of overproduction. Factories capable of producing large volumes of goods could quickly saturate markets if demand slowed. This dynamic became particularly visible during periods of economic contraction, when purchasing power declined. Highly mechanized industries sometimes found themselves with enormous production capacity, but insufficient demand to absorb the output. Machines that were designed to maximize efficiency could amplify the effects of market downturns. Factories continued producing at high speeds until inventories accumulated and operations were forced to slow or shut down. In these moments, technological capacity did not prevent economic disruption. It sometimes intensified it. Another area where the historical narrative becomes less clear involves the geographic distribution of industrial mechanization. Large mechanical systems were concentrated in specific regions. Heavy industry clustered around access to raw materials, transportation infrastructure, and energy resources. Steel production concentrated around the Great Lakes. Automobile manufacturing developed around Detroit. Large-scale agricultural machinery transformed certain regions of the Midwest. But these technological concentrations did not affect the entire national economy evenly. While some regions experienced rapid industrial expansion, others faced prolonged economic stagnation. Rural communities sometimes lost population as mechanized agriculture reduced the need for farm labor. Smaller manufacturing towns struggled when production consolidated into larger industrial centers. These regional disparities appear only occasionally in simplified accounts of technological progress. The machines expanded productivity, but their benefits were distributed unevenly across the landscape. Historical photographs from the era occasionally capture this contrast. One image might show a vast factory hall filled with advanced machinery. Another photograph from the same decade might show unemployed workers gathered outside closed industrial gates. Both scenes belong to the same economic system, yet they are rarely placed side by side within the dominant narrative. A similar pattern emerges when examining infrastructure projects often associated with economic recovery. Large construction programs introduced massive mechanical equipment, earth-moving machines, concrete mixers, turbines, and electrical generators. These projects generated employment and expanded national infrastructure. At the same time, they required enormous financial investment and long construction timelines. While the finished structures later symbolized stability and progress, the immediate economic effects during construction were not always straightforward. Some projects took years to complete before producing measurable economic benefits. During those years, workers and communities remained exposed to broader economic uncertainty. Another detail that complicates the story appears in contemporary engineering and management documents. Many technical reports from the early 20th century focused heavily on efficiency metrics. Engineers calculated optimal speeds for machinery, maximum production volumes, and ideal staffing ratios. These documents reveal a primary concern with operational output rather than social stability. Machines were designed to increase efficiency within industrial systems. Their ability to resolve wider economic problems was often assumed rather than directly analyzed. This distinction rarely appears in simplified narratives. The machines solved production problems, Whether they solved broader economic challenges remained a more complicated question. Even the visual language used to represent mechanization contained subtle contradictions. Promotional photographs of factories often emphasized order and precision. Machines appeared clean, powerful, and carefully arranged. Workers appeared disciplined and organized within the mechanical environment. But other images from the same decades revealed different conditions. Overcrowded factory floors, workers performing dangerous tasks near heavy machinery, industrial accidents recorded in local newspapers. These scenes existed alongside the celebrated images of technological progress. They were not necessarily hidden, but they rarely occupied the center of the story. None of these observations invalidate the role of machines in expanding industrial capacity. Mechanical systems undeniably transformed production and infrastructure across the United States. The scale of these changes remains difficult to exaggerate, yet the closer the historical record is examined, the less tidy the relationship between mechanization and economic recovery appears. Machines increased output, but they also reorganized labor. They expanded industrial capacity, but sometimes amplified market instability. They concentrated economic activity in certain regions while leaving others behind. These details do not fully overturn the familiar narrative, but they begin to suggest that the role of machines in pulling the American economy away from collapse may have been more complex than the simplified story usually implies. The machines were powerful, but their effects were not always as straightforward as the narrative suggests. As historians began to examine the industrial transformation of the United States in greater detail, another pattern gradually became visible. The story of machines saving the economy often depended on a particular way of describing their effects. Not necessarily false, but simplified. One of the most common simplifications involves the idea that mechanization fundamentally liberated human labor. In popular narratives, machines appear as tools that remove the most difficult physical burdens from workers. Steam engines replaced human muscle. Electric motors reduced the need for exhausting manual effort. Automated systems took over repetitive tasks. The implication is clear. Machines made work easier, yet contemporary accounts from industrial workers frequently describe a different experience. Instead of eliminating physical strain, machines often reorganized it into new forms. The introduction of powered equipment frequently accelerated the pace of production. Machines could operate continuously, and workers were expected to maintain the same rhythm. Rather than lifting heavy loads by hand, workers might now be responsible for monitoring several machines at once. Instead of shaping materials manually, they might feed components into rapidly moving mechanical systems. The work changed, but it did not necessarily become easier. Some historians studying factory labor in the early 20th century describe mechanization as a shift from physical exhaustion to rhythmic discipline. Workers no longer controlled the speed of their tasks. The machine determined the tempo. Production lines moved at fixed speeds. Conveyor belts continued regardless of fatigue. The mechanical system imposed its own schedule. This transformation often appears only briefly in mainstream historical summaries, yet in labor reports and factory records it appears repeatedly. Another simplification involves the scale of human costs associated with industrial expansion. Industrial machinery dramatically increased productive capacity, but it also introduced new risks. Large machines concentrated enormous energy within confined spaces. Steel presses, high-speed saws, conveyor systems, and mechanical hammers operated with forces far beyond human strength. In industries such as mining, steelmaking, and logging, accidents involving heavy equipment became common topics in local newspapers and labor reports. The historical record includes numerous references to crushed limbs, fatal falls, and mechanical failures. However, these details rarely occupy a central place in the narrative of industrial recovery. They appear as side notes. The machines themselves remain the dominant symbols. Another distortion appears in the way the speed of mechanization is sometimes described. Popular historical accounts often portray technological change as sweeping rapidly across society. A new machine appears. Industries adopt it quickly, and productivity rises across the economy. But economic historians studying industrial records often describe a slower, uneven process. Many machines were expensive and required specialized infrastructure. Factories did not immediately replace older equipment. Instead, mechanical upgrades often occurred gradually over decades. Some factories continued operating with mixed systems, older manual methods alongside newer machines. In agriculture, the pattern was even more uneven. Large mechanized harvesters appeared in certain regions, but smaller farms often continued using traditional equipment for years or even generations. This uneven adoption complicates the idea that machines instantly transformed the economy. Instead, mechanization spread through a patchwork of experiments, investments, failures, and gradual improvements. Another difference emerges when comparing different types of historical sources. Public narratives, museum exhibits, educational materials, and popular documentaries tend to emphasize the machines themselves. They focus on invention, a new engine design, a revolutionary production system, a powerful turbine generating electricity. These inventions appear as turning points. But when researchers examine corporate records, engineering journals, and industrial management documents from the same period, the focus often shifts. The most detailed discussions rarely center on invention alone. Instead, they revolve around efficiency. Engineers measured machine utilization rates. Managers calculated cost reductions. Production planners studied the optimal arrangement of equipment on factory floors. These documents reveal a quieter reality. Industrial machinery was often introduced not because it revolutionized society overnight, but because it slightly reduced production costs within highly competitive markets. A machine that reduced labor costs by a small percentage could gradually reshape an industry, but that transformation often unfolded slowly. Another comparison reveals an additional layer of simplification. When early 20th century observers described mechanization, they often focused on national productivity statistics. Output per worker increased in many sectors. Industrial capacity expanded. However, when examining personal accounts, letters, diaries, and oral histories, the language becomes different. Workers rarely described machines as symbols of national progress. They described schedules, wages, noise, and fatigue. They wrote about learning to adapt to new equipment, about the pressure to maintain production quotas, about the uncertainty that accompanied technological change. These perspectives rarely contradict the statistical evidence, but they emphasize different aspects of the same transformation. Machines increased production, but they also changed how people experienced work. Another subtle distortion appears in the idea that mechanization was universally welcomed. Many historical accounts acknowledge occasional labor resistance, but these moments are often portrayed as temporary obstacles to inevitable progress. Yet labor strikes, protests, and negotiations around mechanization were persistent features of industrial history. Workers frequently demanded safety protections, wage guarantees, or limits on the speed of production lines. Employers, meanwhile, argued that mechanization was essential for maintaining competitiveness. The resulting conflicts did not stop mechanization, but they reveal that its effects were not universally perceived as beneficial. Over time, the simplified narrative gradually filtered out many of these tensions. Machines became symbols of progress rather than objects of negotiation. Industrial growth became associated with national strength. The complex experiences of workers, engineers, managers, and communities became secondary to the larger story of technological advancement. This simplification did not necessarily emerge from deliberate distortion. It also served practical purposes. Historical narratives that emphasize clear progress are easier to teach. They provide recognizable turning points. They offer visual symbols, machines, factories, infrastructure that represent transformation. Complex social processes are harder to compress into a simple storyline. Machines provide a convenient focal point. They are visible, they are measurable, they appear decisive. And so, over time, the story of industrial recovery becomes increasingly centered on them. But when multiple types of evidence are placed side by side, production statistics, engineering documents, labor reports, and personal accounts, the narrative begins to look less uniform. Machines were important, but the way their importance has been described may have gradually simplified a far more complicated historical process. If the simplified narrative of machines driving economic recovery appears repeatedly across textbooks, museums, and documentaries, another question naturally follows. Why has this version of the story remained so stable? The answer may lie less in deliberate distortion and more in the practical advantages that such a narrative provides to modern institutions. One of the most important contexts is the role of the modern state during periods of economic reconstruction. Large-scale industrial projects have often required coordination between government policy and private industry. Infrastructure programs, public works initiatives, and industrial subsidies frequently involved enormous mechanical systems, dams, turbines, construction machinery, and manufacturing equipment. These projects were not simply economic investments. They were also visible demonstrations of national capability. A massive hydroelectric dam, for example, produces electricity and supports regional development. At the same time, it functions as a physical symbol of state capacity. Its scale communicates organization, planning, and technological mastery. When governments present such projects to the public, machines become powerful visual language. Steel structures rising from rivers, turbines spinning within power plants, excavators reshaping landscapes. These images convey a sense of control over uncertainty. During periods of economic crisis, that symbolism can carry significant political value. The narrative that machines helped pull the nation back from collapse reinforces the legitimacy of large public investment programs. It suggests that technological expansion, coordinated through government planning, can restore stability. Importantly, this does not require a hidden agenda. The alignment between technological achievement and political legitimacy often emerges naturally. Large machines are visible. They create measurable outputs. They produce infrastructure that remains in place for decades. In contrast, many other economic recovery mechanisms, financial reforms, regulatory changes, or gradual shifts in labor markets are less visually dramatic. They are difficult to represent through images. Machines therefore become convenient symbols for complex economic transformations. A similar dynamic appears in the symbolic association between technology and civilization. Since the 19th century, industrial machinery has frequently been presented as evidence of modernity. Nations with advanced industrial capacity are often described as technologically advanced, economically developed, and socially organized. This association influences the way historical narratives are constructed. When a society emphasizes its technological achievements, it reinforces the idea that progress is measurable through engineering and industrial capability. Factories, railroads, power plants, and mechanized agriculture become markers of national advancement. Within that framework, it becomes natural to frame economic recovery in technological terms. If machines symbolize modern civilization, then the expansion of machines can easily be interpreted as proof that the system is functioning again. Another factor involves the interests of industrial organizations themselves. Manufacturing companies, engineering firms, and equipment producers have historically documented their achievements in ways that emphasize technological innovation. Corporate histories often highlight new machines, improved processes, and increased productivity. These narratives serve understandable purposes. They demonstrate expertise. They attract investment. They reinforce the reputation of engineering progress. When historians and journalists later examine these materials, the technological achievements remain highly visible. Other dimensions, labor negotiations, social disruptions, regional inequalities, may appear less prominently in the same sources. The result is not necessarily a false narrative, but it can become a technologically centered one. Industrial archives tend to preserve the history of machines very well. They sometimes preserve the social context less thoroughly. Another practical advantage of machine-centered narratives is their stability. Machines provide clear milestones in historical timelines, the introduction of a specific engine design, the construction of a large dam, the opening of a mechanized factory. Each event can be dated, photographed, and documented. Social transformations, by contrast, often unfold gradually. Changes in working conditions, migration patterns, and labor relations develop over years rather than at a single moment. For educators and museum curators, technological milestones provide a clearer structure for explaining history. Visitors can stand beside a machine and imagine its role in the past. Abstract economic forces are harder to display in physical form. As a result, exhibitions about industrial history often revolve around objects: steam engines, turbines, tractors, assembly lines. Each machine represents a chapter. The broader economic system becomes the background. This method of storytelling is effective, but it subtly reinforces the idea that machines were the primary drivers of change. Another dimension involves national identity. In the United States, industrial ingenuity has long been celebrated as a defining national trait. Stories of inventors, engineers, and large-scale infrastructure projects contribute to a cultural image of practical innovation. Within this cultural framework, machines naturally occupy a central place in historical memory. When economic crises occur, narratives emphasizing technological resilience align comfortably with existing national myths. The country solves problems through engineering. Industry expands. Production increases. Recovery follows. These stories do not necessarily ignore other factors, but they emphasize the aspects that resonate most strongly with cultural expectations. Over time, the repetition of this narrative strengthens its credibility. Each new retelling reinforces the association between machines and recovery. Eventually, the connection begins to feel almost inevitable. Yet when the broader historical evidence is examined, the situation appears more complex. Economic stabilization involved financial reforms, labor policies, international trade adjustments, and demographic shifts alongside technological development. Machines played a role, but they operated within a larger system shaped by political decisions, social negotiations, and economic constraints. Focusing primarily on machines does not necessarily produce an incorrect story. However, it may produce an incomplete one, and the reasons that this incomplete version remains so prominent are themselves part of the historical process. Machines provide powerful symbols that are visually compelling, politically useful, and culturally familiar. That combination may help explain why they have remained at the center of the story for so long. If the dominant narrative of industrial recovery centers on machines as the primary engines of progress, another layer of historical material exists that rarely enters the main storyline. These sources do not necessarily contradict the presence of powerful machines in the American economy. In many cases, they describe the same equipment, the same factories, the same industrial systems. What differs is the perspective. Instead of focusing on technological milestones, these documents often describe the social environments that developed around mechanized production. One group of sources comes from labor reports produced during the early and mid-20th century. Government labor departments, trade unions, and investigative commissions regularly documented working conditions inside industrial facilities. Their reports recorded wage structures, accident rates, work schedules, and the physical organization of factory floors. When these reports are read alongside the familiar narrative of industrial progress, a more complicated environment appears. Mechanized factories often operated with strict time discipline. Workers were required to maintain the pace dictated by machines, sometimes for shifts lasting 10 or 12 hours. Production schedules were calculated to maximize equipment usage, which meant that downtime for rest or adjustment could be limited. Many reports describe workers adapting to a constant mechanical rhythm. The machines defined the tempo of the workplace. This was not necessarily a deliberate attempt to impose hardship. Industrial managers were often focused on maximizing output and minimizing costs. Mechanical systems required continuous operation to achieve efficiency, but the consequence was a work environment structured around machines rather than around human pace. Another set of materials comes from technical engineering documentation, engineering journals, maintenance manuals, and factory planning records contain extensive information about the performance of industrial machines. These documents describe maintenance cycles, failure rates, lubrication systems, and mechanical tolerances. They also revealed the degree of constant oversight required to keep large mechanical systems operating. Many machines demanded frequent inspection. Bearings wore out, belts slipped. Boilers required careful monitoring to prevent pressure failures. Complex industrial equipment did not function autonomously. Behind the visible machinery stood teams of mechanics, engineers, and technicians responsible for keeping the systems operational. These workers rarely appear in simplified narratives of technological progress. The machines appear to operate independently, but the documents reveal a network of human labor required to maintain them. Other rarely cited sources come from regional economic studies conducted during periods of industrial change. Economists and sociologists studying local communities sometimes documented how mechanization affected entire regions rather than individual factories. In agricultural areas, the adoption of large mechanized equipment reduced the number of workers required for planting and harvesting. Farms expanded in scale while rural populations gradually declined. Some communities experienced steady outmigration as agricultural labor became less necessary. Similar patterns appeared in certain manufacturing regions. When factories introduced more efficient machines, the immediate effect was often increased production with fewer workers. Over time, some displaced workers found employment in other sectors. But the transition could take years. Local newspapers from industrial towns occasionally described this adjustment period in practical terms. Families relocating, younger workers leaving for larger cities, older workers struggling to adapt to changing industrial skills. These accounts rarely appear in national narratives about technological progress. They remain scattered in local archives. Another category of overlooked material involves safety and accident investigations. As industrial machines grew larger and more powerful, they also became more dangerous when failures occurred. Investigations into factory accidents sometimes documented mechanical malfunctions, inadequate safety guards, or insufficient training for workers operating complex equipment. The resulting reports provide detailed descriptions of how machines functioned within real industrial environments. They also show how frequently industrial systems required modifications after accidents revealed design weaknesses. Some machines were redesigned multiple times before reaching safer configurations. This process of trial, error, and adjustment rarely appears in simplified accounts of technological success. Yet it was a routine part of industrial development. A different type of source comes from early industrial sociologists and workplace observers. During the early 20th century, several researchers conducted direct observations inside factories. Their studies examined how workers interacted with machines, how production schedules influenced behavior, and how industrial environments affected social relationships among workers. These studies often described factories as complex social systems rather than purely mechanical ones. Workers developed informal methods for coping with production pressure. Small adjustments in timing or coordination sometimes helped workers manage the pace of machinery. Managers, meanwhile, experimented with different organizational methods to maintain productivity while reducing labor conflict. These dynamics reveal that mechanization did not simply replace human activity, it reorganized it. The industrial workplace became a negotiated space between mechanical efficiency and human adaptation. Another group of historical materials comes from corporate correspondence and internal planning documents. These records sometimes show that decisions to introduce new machines were driven less by technological enthusiasm than by competitive pressure. When one company adopted a more efficient machine, rival firms often felt compelled to follow, not because the machine transformed the industry overnight, but because failing to adopt it could gradually raise production costs relative to competitors. Mechanization therefore spread through incremental competitive adjustments rather than through dramatic breakthroughs alone. This process rarely produces a single decisive moment. It unfolds through dozens of small decisions made across many companies over time. Taken together, these lesser-known sources do not overturn the visible reality of American industrial machinery. Factories expanded, machines grew larger, production increased, but they add layers of context that rarely appear in simplified narratives. They show machines operating within complex social, economic, and technical systems. They reveal the human labor required to maintain industrial equipment. They document regional transitions that unfolded gradually rather than instantly. And they illustrate how technological change was often negotiated, adjusted, and sometimes resisted before becoming routine. None of this contradicts the presence of powerful machines in the story of economic recovery, but it suggests that the machines themselves were only one visible part of a much larger and more complicated process. By the time the historical record is viewed through multiple layers, industrial production statistics, labor reports, engineering documentation, regional studies, and contemporary accounts, the story of machines pulling the American economy back from collapse begins to appear less like a single explanation and more like one visible thread within a larger fabric. The machines were real. Their impact was substantial. Factories expanded their capacity. Infrastructure projects transformed landscapes. Agricultural equipment increased the scale of farming. Industrial systems produced goods at levels that would have been impossible only decades earlier. None of this requires reinterpretation. What becomes less certain is the assumption that machines alone, or even primarily, drove the stabilization of the economic system. The broader evidence suggests something more complex. Industrial machinery functioned inside networks of finance, labor, policy, and infrastructure. Machines increased production capacity, but markets still determined whether that production could be absorbed. Factories could produce goods rapidly, but employment levels depended on demand, wages, and broader economic conditions. Machines did not operate independently from the rest of the system. They amplified the forces already present within it. At times, those forces encouraged recovery. At other times, they intensified instability. This observation does not invalidate the visible role of technology in modern economic life, but it challenges the idea that technological progress alone explains historical outcomes. Another assumption that begins to weaken involves the direction of causality. The familiar narrative often suggests that machines created economic growth. Yet in many historical cases, the relationship may have worked in the opposite direction. Economic expansion created the conditions that allowed machines to spread. Factories invested in new equipment when credit became available. Infrastructure projects emerged when governments allocated funding. Agricultural mechanization accelerated when farm markets expanded. Machines did not necessarily initiate these developments. They often followed them. In this sense, machines may have been accelerators rather than origins. They increased the speed and scale of processes that were already unfolding through political decisions, financial systems, and social change. Another assumption concerns inevitability. When industrial history is told through a sequence of machines, steam engines, assembly lines, turbines, tractors, it can appear as though technological development followed a predetermined path. But the scattered evidence from engineering experiments, abandoned designs, and failed industrial ventures suggests that many alternative paths once existed. Not every machine succeeded. Some technologies were introduced and quickly abandoned. Others were delayed for decades because they proved too expensive or difficult to maintain. Certain industrial systems evolved slowly through compromise rather than through dramatic innovation. The final configuration of machines that appears in museums and textbooks represents the survivors of a long process of selection. Many other possibilities disappeared along the way. This realization subtly alters how the story is interpreted. Instead of seeing machines as the inevitable drivers of progress, it becomes possible to see them as outcomes of historical choices, choices influenced by economics, politics, engineering limitations, and social negotiation. Another uncertainty emerges when examining the scale of technological impact across different communities. Industrial machinery often transformed certain regions dramatically, while leaving others relatively unchanged. Large cities with access to capital and infrastructure became centers of industrial growth. Smaller towns sometimes struggled to adapt as economic activity concentrated elsewhere. For individuals living within those communities, the meaning of mechanization could vary widely. In one location, machines might represent new employment opportunities. In another, they might coincide with job displacement or migration. Both experiences belong to the same historical process, yet simplified narratives rarely capture that diversity. The broader lesson is not that the role of machines has been misunderstood entirely. Rather, it may have been compressed into a form that emphasizes clarity over complexity. Machines provide visible markers of change. They are easy to photograph, display, and describe. They fit neatly into chronological timelines. But economic systems rarely operate with such simplicity. They evolve through interactions among institutions, technologies, policies, and human decisions. Machines participate in those interactions. They do not fully define them. As a result, the familiar story that large industrial machines pulled the American economy back from the edge of collapse may function more as a symbolic summary than as a precise explanation. The machines represent recovery, but they may not fully explain it. Historical narratives often depend on symbols that help organize complicated events into understandable patterns. In the case of industrial history, machines have served that role particularly well. They stand in for productivity, innovation, and national capability. Yet when the underlying evidence is examined more carefully, the machines appear less like solitary heroes and more like components within a much broader system of change. The deeper question, therefore, may not be whether machines played an important role. They clearly did. The question is whether the prominence of machines in the story has quietly shaped how the rest of the history is understood. When machines occupy the center of the narrative, other forces naturally move toward the background. Financial reforms, labor movements, regulatory frameworks, demographic changes, and international economic shifts. Those forces remain present, but they become harder to see. And that leaves us with a final uncertainty. If the machines we remember so clearly are only the most visible part of a much larger historical process, then how much of the story of economic recovery has been structured around what was easiest to display rather than what was most decisive?